Welcome to The Explainer. Today, we're diving into a process that's pretty much everywhere you look, but almost nobody ever sees. It's a hugely sophisticated industrial process that touches your life constantly.
I mean, think about it. You see this stuff all the time. It looks so simple, right? Like it was just printed on a regular printer. But here's the thing. The tech needed to print on things that are flexible or stretchy or even bumpy and do it at lightning speed, that is a whole different ballgame.
We're talking about a process called flexography, or flexo for short, and it is the dominant way things get printed in the packaging world. We're talking the plastic on your snacks, your grocery bags, even the cardboard boxes showing up at your house. And to get that perfect print every single time, you have to get a ton of different things. We're talking digital design, ink chemistry, mechanical engineering, all working together in perfect tune. It's a real symphony. So today, we're going to pull back the curtain on this unseen performance, all the way from a basic idea to that finished package you see on the shelf.
All right, so every symphony needs its sheet music, right? Well, in Flexo, the sheet music is the digital design file. This file has every single instruction that tells the massive printing press exactly what to do.
And this is way more than just making a design look good. Every single one of these stages follows a really strict set of technical rules. These are called specifications, and they make sure that the cool, creative idea can actually be printed on a press that's flying along at hundreds of meters per minute. It's all about making art reproducible at an insane scale.
Okay, let's get into a real-world example here. Look at this text. It's what we call reversed or knocked out of a background made of a few different colors. Now, a flexo press prints each color one after the other, so there can be these tiny, tiny shifts in alignment. You'd get these ugly gaps between the colors and the text. So to fix that, a smart trick is to use what's called a holding line, just a thin outline in one dark color. It completely hides any of those little movements. Super clever.
And hey, even something as simple as a barcode, it has its own very strict set of rules. For instance, the bars have to be printed in the same direction that the packaging material is running through the press. Why? Well, if you print them sideways, the pressure of the press can actually smear the bars, making them wider and totally unscannable. And you can imagine that's a very expensive mistake to make.
You see, the big takeaway here is that flexo printing isn't magic. It's all about physics. A designer can't just make a color fade away into nothingness. The press has a real physical limit. There's a smallest possible dot it can actually print. If you try to go smaller than that, you just get a hard, ugly line where the print just stops. The art has to respect the limits of the machine.
Okay, so we've got our sheet music. Now, let's meet the instruments in our orchestra. This is the actual hardware that takes that digital blueprint and makes it real.
So first up, we have the printing plate. This is what actually carries the image. The best way to think of it is like a really, really high-tech rubber stamp that's made from that digital file. And the magic is in the material it's made from. It's this soft, flexible stuff called photopolymer. That means it can wrap around a cylinder and print on all sorts of things, even on the bumpy ridges of a cardboard box.
And this plate gets mounted with a special kind of tape. And no, this is not your average double-sided tape. It's this super-engineered foam that basically acts like a shock absorber. Its whole job is to get what's called the perfect kiss impression. That means the absolute lightest touch possible to transfer the ink perfectly. If you press too hard, you crush the image. Too soft, and the ink doesn't transfer at all. It has to be just right. And now, we get to the Analox roller. And I need you to forget everything you think you know about rollers. Because this is the real heart of the press. I'm not kidding. This is probably the single most important part for getting consistent color. It's not just a roller. It's a super precise instrument for measuring ink. Get this. Its ceramic surface is covered in millions of microscopic cells. We're talking sometimes over 1,000 of these tiny pockets in a single inch. And each one is laser engraved to hold a perfectly measured microscopic amount of ink. That's how the press makes sure the exact same amount of ink gets to the plate over and over and over again. And here is where the science gets really, really cool. You know those tiny little dots that make up the image on the printing plate? Well, they need to sit perfectly on top of the Analox roller's surface. If the cells in the Analox are too big, the dots will actually dip down inside them. That gets them all smeared with ink and makes the print look dirty. So the size of the cells has to be matched perfectly to the level of detail in the image. It's just a beautiful piece of engineering.
Okay, so our instruments are all tuned up. Now it's time to create the harmony, and that means diving into the science of how you get perfect accurate color, not just once, but millions of times. So flexo inks are basically these complex chemical cocktails. And you know, the funny thing is the pigment, the part that actually makes the color, is usually a pretty small part of the mix. The real heavy lifting is done by what's called the vehicle. That's the resin, which is like the glue that makes it stick, and the solvent, which keeps it all liquid and controls how fast it dries. That vehicle is what makes sure the ink doesn't just rub off when it's being shipped or sitting on a shelf. So how in the world do you make color predictable? Well, you have to run a very controlled test. A standardized target, like this one with over 1,600 color patches, gets printed using the exact same ink, plate, tape, and material that's going to be used for the final job. This basically creates a unique fingerprint, a snapshot of how that very specific combination of things creates color. Then, every single one of those color patches gets measured with this incredible device. It's called a spectrophotometer, and it doesn't see color the way our eyes do. Instead, it measures the exact amount of light bouncing off the patch across the entire spectrum. It turns color, which can be subjective, into pure, cold, hard data. And with that data, we can calculate something called delta E. Think of it as just a single number that tells you the distance between two colors. So instead of people arguing about whether a color looks right, the printer and the brand can just agree on a number. If the printed color is, say, under a delta E of 2 compared to the target, it's a match. It's a simple, objective way to talk about color. All of that measurement data gets bundled into one super important file, an ICC profile. This is the press's unique color fingerprint, or its color map. It basically defines the entire range of colors, the gamut, that this specific press setup can possibly create. And that file is the key to everything. It lets you predict the final results, make accurate proofs, and it means there are no nasty surprises when it's time to print for real.
All right, let's put it all together now and watch the final performance. This is where the Symphony comes to life, in the high-speed press run, churning out millions of perfect packages. And here you can see the whole journey, the entire Symphony in one flow. It starts with the first note of the design concept, moves through all the prep press and plate making, and hits its crescendo with the finished package. Every single step is part of this repeatable, super controlled process, all built for consistency on a massive, massive scale. And while the press is running, the operator isn't just standing there watching. They're like the conductor of our orchestra. They're constantly using tools to measure all these key variables. Things like ink density, how much the dots are spreading, if the colors are lining up perfectly, the printing pressure. And they're making tiny adjustments the whole time to keep the entire Symphony perfectly in tune. So from a digital file to a physical product, Flexography is a remarkable performance of communication, precision, and science. The collaboration behind that simple object in your hand is a testament to an entire industry playing in perfect harmony. It really makes you wonder, doesn't it?